This is Aristotle, and then we're gonna try to understand what Galileo has to say. Galileo was born in 1564, and he lived until 1642. All right. So the Galileo hypothesized that heavy and light objects both fall at the same time. And he also said objects fall not with constant velocity but with constant acceleration. So objects fall with constant acceleration, he said, proving the Aristotle idea wrong. Aristotle said, remember, object fall with constant velocity, but he said with constant acceleration. That makes a difference. He said constant velocity and he said constant acceleration. That's a big difference. And number three, he said the earth is not center of the universe, so is not center of universe, lead to birth of heliocentrism. So the name is not a big deal here, but the idea, he said the earth is the center of the universe, leading the birth of geocentrism. He is saying the earth is not center of the universe, leading the birth of heliocentrism. So that tells us almost all ideas. The first Aristotelian idea, heavy objects fall faster than light objects. Galileo proved it wrong. And the second idea, objects fall to earth. The third idea, objects in motion slow down because they get tired, and objects fall with constant velocity. And the last one, all proved wrong. Now let's see what Newton has to say. Newton. He was born in 1642, 1727. I believe he was born in the same year Galileo died. Yeah, nature works in a mysterious way. The Newton was born in the same year Galileo was died. So the Newton gave us the entire picture of the universe. His three laws of motion capture the entire laws of mechanics, and then his universal law of gravitation allow us to understand the gravity. So let's see his laws. The first one is net force. Net force is 0, telling us that in an inertial reference frame, object in motion remain in motion, and object at rest remain at rest until it pushed by an external force, proving Aristotle idea totally wrong. Remember what Aristotle said. He said objects slow down because that object get tired, but Newton saying no, there is no such thing. Objects do not slow down because they get tired. They slow down because there is other mechanism is there. So the mathematical way of describing that is net force is 0, saying that in an inertial reference frame, object at motion remain at motion and object at rest remain at rest until it pushed by some external force. Let's see what his second law has to say. His second law is F equal ma, which can be written as acceleration is force over mass, and acceleration and force is a vector quantity. So it's saying that the acceleration is a proportional. The acceleration of object is a proportional to the force and inversely proportional to the mass. And then his third law said F, who's telling us is a law for the rocket. There's simple law put man on the moon some 40 years ago. So that tells us that the force of object A and B is proportional to the force of object A and B in same magnitude but opposite direction. And his law of universal law of gravitation tells us that the force is G is a gravitational constant, and then m1 m2 over r squared tells us that the force, the attraction between two objects is the product of the mass of both objects and is inversely proportional to the square between two object distance. So that's the Newton idea of gravity. So so Newton thought that gravity was an instantaneous force. One day Newton was he was like 25 years old, a math student of Cambridge University. So one day in 1643 he was sitting under a tree thinking of all the problems, mathematical problems. All of a sudden he saw an apple fall from above, and with the fall of this apple he looked up and he saw moon, and he asked a simple question. What did he ask? He asked, if an apple fall, does the moon also fall? He wanted to calculate the motion of the falling moon, and he also want to understand why don't moon fall? If apple fall, moon also has to fall. But the mathematics of his time didn't allow him to calculate that because it wasn't sophisticated enough. So he ended up inventing a new branch of math. Now we call calculus. So the falling apple and asking question that if apple fall, does the moon also fall? That not only end up becoming the greatest question any human being ever asked since we separate from our ancestor monkeys in Africa some 7 million years ago. But also that simple question led to the birth of calculus and led to the birth of gravity. Is kind of unified the celestial with the celestial, the laws that govern the object in the heaven is the same law that governs ordinary object like apple in the world. So he gave the world a beautiful law, the universal law of gravitation. We can calculate exactly what is the force between two objects. But unfortunately, Newton himself didn't understand what causes the gravity, and that brings Einstein to the picture